Welcome to our autopilot project. So today we're going to show you in this video the aircraft we got. As you can see right here. So we'll tell you the type we have, and then afterwards we'll show you the sensors that we have. Because for an autopilot, you need to know the aircraft and you need to know how to control the servo it has on it, and then how to also control what turns the blade. Okay, so I'll call my colleague Makasin to come and do the introduction.
Hi, what I'm going to do today is introduce you to our aircraft and what makes up the aircraft we bought. Now this is our aircraft. It's an ERASER 250 model. It came together with the transmitter and the receiver on board the aircraft. So as this transmits the signal, it's received by this one, and the appropriate actuators are being activated to bring about the movement. So that's how come you control the aircraft. That's how it was meant to be controlled. Now, when it came, because we are building an autopilot and that should fly the aircraft autonomously, we had no need for this one. So we stripped it off. This the receiver.
You said strip off, so I can throw them away, right?
Yeah, you can.
Okay, off it goes.
Then it also came with a battery. A battery, it's 850 milliamp, 7.5 volts. Dynamo battery, but as you can see, the battery gave up on us during our second testing, so we had to go in for an alternate power supply, which you will see later on in this series. This is also the belt that transmits power to this tail rotor. This is the main rotor of the aircraft. This is the tail rotor. This belt transmits power from the main rotors to the tail rotors to get it spinning. Okay, but the belt also gave up on us. Almost getting to the end of our project, so we are doing away with the photo. So that's the main reason why this aircraft cannot fly. The ERASER 250 has 4 main servos that control the aircraft together with the brushless motor. Now, servo 1 here, as you can see, controls the rudder. The rudder, what it does is it controls the yawing of the helicopter along the z-axis. Now, how it achieves this? By changing the pitch of this blade to vector air either to the left or to the right in order to control the yawing of the aircraft. So this is the servo that does that. It's that over here. Then we have the elevator servo. There is it. It controls the pitching of the blade up or down to pitch the nose of the aircraft down or up. Then we have 2 other servos here. We've modified them to work together. Initially when it came, they were supposed to work separately, but we've modified them to work together. So as you can see, these 2 servos either they move in opposite direction. Whilst one is moving up, the other moves down. And what they do is they control the banking of the aircraft. Now, one more thing I would like to talk about, the most important thing, is our brushless motor. It's very small down here, and it's being controlled through an electronic speed controller. So we send our signals through this electronic speed controller, and it also intends to send the signal to the motors to give it its speed. So basically that's how the aircraft is controlled by the various systems on board. Thank you.
So we've got our servers, we've got our sensors, we've got our aircraft, right? So what's now left is to show you how we've actually connected the whole thing together. Okay, now looking at this board, you can see that it's already introduced to the board, right? We have our microcontroller here. Okay, now the microcontroller it has I/O pins, 32 I/O pins, right? So how are they connected? You see these are where our sensors are all in, right? You see this wire, okay, it all goes to the I/O pins in here. So whenever the microcontroller wants to communicate with any of these sensors, it will have to pass through these sets of I/O pins here. Okay, now how do we control our servers? Now we've been used to our servers, right? You see them all here. So basically what we've done is we have this long cable here, you see. So this is what we've used. This is what we've used to communicate with our servers. So basically, if you have this thing, if you have seen them before, you will notice that the receiver was somewhere here. Right? Was somewhere where this is. So because we don't need the receiver anymore, so what we did was we created another board, which is called the power distribution board. So now this board, the receiver the ESC has what's called DEC, which is battery eliminated circuit. And what that does is it supplies power to all the servers. Because we needed to do that, so we needed to power our supply to the servers. So we have to use another way of doing it. So we have this board, okay, which is the power distribution board. So all that it does is just have the connections for all the servers on it. So when the 5 volts come from here, it will go to all the servers. Okay, so that's our connection. Just to recap, we have this wire here, you see this bunch here, which connects to our servers, and they are the signal wires for the helicopter, and then the sensors here, see the signal wires and the power cables also go on there. Okay, the GPS is here, and then we've added something extra to it. Okay, this is just a normal speaker which we've made so that when it's detecting anything that I ask, it will just sound, make some noise which you would get to hear. Okay, like what Marcus said, my colleague, we cannot use the rudder because the dog gave up on us, and then the battery as well, so we have to find another way of supplying power to that. Okay, so that's our helicopter. We introduce you to our board, introduce you to our sensor, introduce you to the helicopter as well. So the next thing we'll do is, okay, introduce you to the algorithm, that is how the helicopter will actually fly.